Hi class, so this section is 13.5. We are looking at solutions, but not just the solution anymore, the concentration of it. So what is the amount, the value that goes with that solution, the concentration of it? And this part is going to be about mass percent. So generally in life, if you make punch, you can follow the directions. You don't have to follow directions. Nobody really cares unless it's not sweet enough or it's too sweet. But when we deal with things in science, we have to document everything. And that has to be done because if you ever, some of you may not be involved wanting to go into science, but you have to document, because if somebody needs to look at your work, they have to be able to duplicate everything. And you can't just have a solution and not have values to it. It has to have values in order to know exactly what what they need to work with. So in this case, mass percent is the number of grams of solute per 100 grams of solution. Remember, solution is grams of solute plus grams of solvent. And the terms are by mass, or you might see it mass over mass. And that's mass is in regards to grams. So for instance, if we use the sentence of a solution with a concentration of 14% by mass, that immediately means we're dealing with grams. Everything is grams. That contains 14 grams of solute plus 100 grams of solution. And in that 100 grams of solution, some of that is 14 grams of solute. The remainder is the mass of solvent. So to calculate mass percent, we're going to divide the mass of the solute, which is set up here, by the mass of the solution, which is made up of the solute and the solvent. And of course, then we multiply it by 100. So there are other concentrations. We're not going to discuss them here, but your book brings them up, so I'm going to detail them. Some other concentrations are parts per million. We're working with actual parts per 100 because this is out of 100. But there are others, parts per million, which is the number of grams of solute per 1 million grams of solution, and parts per billion, the number of grams of solute per 1 billion grams of solution. Here, again, I took this slide from one of my other classes, so I apologize. It's not the greatest looking. I tried to transfer it over. I use Google Docs, and everything that's given to me is with PowerPoint. So they don't transfer over well. But this is an easy question, and it helps you get into understanding mass percent. When 42 grams of water is added to 8 grams of potassium chloride, the mass percent concentration is 16%. So this would be by mass. It says M and M. So that tells me M over M is what I should say, this is all grams. So how did we get to the 16%? Well, we use the formula. 8 grams of KCl is on top, and you can't just take the 42. That's not enough. The 42 down here is actually going to give you the wrong percentage, which is not 16%. Your solution is the solute plus the solvent. So you have to add these together. That makes 50 grams of solution. And then we divide that, and that times it by 100, and it gives us 16%. So this is 16% potassium chloride solution by mass. It's a pretty simple one. A few of these are a little easy, and then it gets into a little bit more intense. So suppose we want to calculate the mass percent of sodium chloride in a solution containing 15.3 grams of sodium chloride and 155 grams of water. Same thing, everything applies. We look at what we're given. We're given 15.3 grams of sodium chloride. We're also given 155.0 grams of water. We need to find the mass percent, and how do we do that? By using the formula that's been given to us. So we plug everything in, and you can see that the solute and the solvent have been added together. That produces 170.3 grams. The grams cancel out, and we have a percentage, is what exactly we should have, because we're working with percent. So in this case, the units have to cancel out. So we have an 8.9% of sodium chloride solution by mass. Okay. So here's a little harder one that your book's giving you. A water sample from the bottom of Lake I guess it's Nyos? Forgive me if I'm not saying that right. Contains 8.5% carbon dioxide by mass. Determine how much carbon dioxide in grams is contained in a 28.6 liter water solution. So up until this point, we've been figuring out how to get a mass percent. But now we're actually going to use it to figure out, what is this question asking for? It's asking for how much CO2 in grams is contained in this much volume of water, of solution. So we need to take some steps here to figure out how to do that. And we're given, I jumped ahead, we're given 8.5% CO2 by mass. We are given a volume. And when you don't know how, if you're stuck on something, you should ask yourself, can you use density? Because some students still forget that we can use density in a lot of problems. And so in this one, density is not given to you in the exact problem, but it is given to you here. So if density is given to you 99% of the time, you have to use it. So in this case, we need to we're given volume, but how do we get to grams? That's through density. Density will help you with that, but you have to convert it to mils in order to get to that. So here's the stepping stone for this. We're going to start with the solution. The solution was the 28.6 liters. I know it's down here, but I really don't want to look at that yet. And then we have to convert it to mils, which is done. From there, we can use the density to cancel out the volume, which leaves us with the mass. And then from there, we can cancel out the mass of the solution, which will provide us with the mass of the sodium, the CO2, which is exactly each step that's here. So this is, again, it's probably new, but this is not difficult. If you figure out the units and you set up the units right, you will get to the end of the problem. And if you've set up the units right, you've most likely set up the numerical values, and that'll get you to the end. So this is 2.5 times 10 to the 3 grams of CO2. You can also use it by flipping it. So we can use it as a conversion. So in this case, we used it in the way of the percent that was given to us, 5.80 grams over 100 grams of solution. But we can also use it to determine grams of a solution, and by flipping it over. So here is the key is to mass percent is grams over solute over 100 grams of solution. But you can flip this in any way that works for a problem. So in this case, same as density, you can, flip them. So a solution that contains 14% of sodium chloride can be used as a conversion factor. You pull out everything, change the percents to grams. So here we have 14.0 grams of sodium chloride in 100 grams of solution. We can use this to convert to sodium chloride, converts to grams of sodium chloride, and then grams of solution. Here's an example to show you what I'm talking about, because that might be a little confusing. A soft drink contains 11.5 sucrose by mass. What volume of the soft drink solution in milliliters contains 85.2 grams of sucrose? Here we're also given another density. So this is asking for the volume in milliliters. That is what our final product has to be. So let's pull out what we know about it. We have 11.5 sucrose by mass. We're given 85.2 grams of sucrose, and we have a density of 1.04. We need to find the milliliters of solution of this. So here is our stepping stone to this. We have our grams. I'm missing something here. There we go. I have an extra slide in there and I shouldn't. So what are the relationships? Pull the relationships out that you know. This is 11.5 grams of sucrose over 100 grams of solution. We have density as 1.04 grams over mils. Now how you go in the stepping stone will tell you how you need to orient these into fractions. So here we start out with the grams of sucrose. So that's not really going to help us. We need to figure out how to get to the next thing. So in this case, we flip it so that the 11.5 grams is on the bottom, so these can cancel out. We're leaving us grams of solution. How do we get rid of grams of solution? Through density, and that will give us the mils that we need. So here's the problem, 85.2 grams of sucrose. We flipped the 11.5% sucrose by mass solution, and then we use the density, and that produces 712 milliliters of solution. Again, it's foreign, but it's not difficult. You guys have handled far more difficult in this class than this. And that's it.